All right, let's start this lesson. And for today, what we're going to do is we're going to start off by first finishing the exercise that I gave you in the previous lesson. We just start off with that one. So we're looking at forgot to silence my phone. Hold on, let me just silence my phone. All right. So let's start off with the exercise. So we have exercise 1, and then it says that for the quadratic 3x squared plus 7x minus 2 equals 0, we're to find the sum and product of its roots. All right. So first thing, we're looking at the quadratic. So from the quadratic, we're going to get, which is 3x squared plus 7x minus 2 equals 0. We get that A is equal to 3, B is equal to 7, and C is equal to minus 2. So if we have to find the sum and the product, we can just simply say alpha plus beta is equal to minus b upon a, which is minus of 7 upon a, which is 3. So that is negative 7 on 3. And then alpha beta is the product, which is c upon a, is going to be equal to negative 2 divided by 3, which is, well, just negative 2, so you don't need to do anything there. Now, another way that we can do this is by just simply taking the quadratic itself and putting it in the form of the squares and products, well, the product and sum form. The product and sum form that I remind you of is this, where alpha plus beta x and then plus alpha beta. So if we put the quadratic in that form, we should be able to get these answers very quickly. So let's do that. So I'm going to start from here. So from the quadratic, I'm going to do another solution for the same thing. So from the quadratic, and the quadratic we're looking at, again, 3x squared plus 7x plus 2 is going to be equal to 0. I'm going to divide first off by 3, right? I'm going to divide both sides by 3. I'm going to get x squared plus 7 over 3x plus 2 over 3 equal to 0. Oh, that's a minus 2. Sorry. So this here is minus, right? And what we do after that is we write this, as I said, in this form, and we see a negative sign out in front here. So let's put a negative sign out in front of something. So I'm rewriting this. I'm going to get x squared minus, open brackets, I put negative 7 over 3. If this multiplied by this, right? If I take these two and I multiply by each other, I'm going to get a positive 7 over 3. So right away I have that, and then the x, and then minus 2 on 3, which is easy to write inside of, in terms of a plus. So just write it in the plus of a plus, and then I have a negative 2 on 3 equals 0. And I can see right away, this here would be my alpha plus my beta, and this here would be my alpha beta. Okay. That's not so difficult to follow. Let's go on to the next one. Now this one is going to be a little bit challenging for some people if you're not confident in your algebra work. So if alpha plus beta, if alpha and beta are roots of 2x squared minus 5x plus 1 equals 0, we're to find a alpha squared plus beta squared, and then b, we're also supposed to find alpha minus beta squared. Now, I gave you a hint, and I told you that what we should do is to first find your alpha and beta, and then expand something like this. Expand alpha plus beta squared, and expand alpha minus beta squared. And you should be able to get a hint there. Right, so let's work on that solution. So from the equation, which we have as 2x squared minus 5x plus 1 equals 0. And I like to rewrite it. Makes it easier for me, right? We rewrite to get x squared. Now I'm dividing out straight through by 2. So I'm going to get x squared minus 5 over 2x, and then I have plus 1 equals 0. And again, I'm going to write again x squared, and it's going to be plus, no, not plus, I have to put a minus outside in front here. And if I put a positive 5 on 2 inside here, that will be my, here will be my alpha plus beta. And then plus 1, this here would be my alpha beta, right? Equals 0. So I'm going to see that alpha, so if I'm comparing to x squared minus alpha plus beta x plus alpha beta equals 0. If I compare to that, we see that alpha plus beta is going to be equal to, look at it here, alpha plus beta is equal to 5 on 2, and alpha beta is equal to this one here, which is 1, right? Oh, let me see something here. This is 5 on 2 because I divide everything by 2, but I didn't divide this by 2. I just have to divide by 2 as well, right? Yeah, okay. So this here is divided by 2. Good. Right, so we have that there. And once we have that, now we have our alpha plus beta, and we have alpha multiplied by beta, and now we have to do the expansion. Now, this is what we have to solve. And I told you we have to try and write this in terms of just simply products and sums only, right? So this and this, only that we can use. And I said expand something to get it. So I'm saying I'm going to write in a different one. I'm going to just write this on the side so you can see the expansions I'm doing. So consider alpha plus beta, right? Squared. If I write that out, it's equivalent to saying alpha plus beta and alpha plus beta. So we multiply the two of them. And then we get that equivalent to alpha squared plus 2 alpha beta plus beta squared, right? Now, if this part over here is equivalent to this part over here, then what I can say is, so I can say alpha squared plus beta squared, I'm taking this and this, is equivalent to saying I can take alpha plus beta, square it, and then minus that 2 alpha beta, alright? So I can say that is equivalent. So this is equivalent to alpha plus beta squared minus 2 alpha beta. Okay, now you can memorize this, or you can just learn how I did it here and realize it's very simple to follow along how to get it. All right, now all I have to do is just do my replacements. So alpha squared plus beta squared is going to be alpha plus beta, which is 5 on 2, square it, minus 2 into a half. And this here is 25 on 4 minus, this here will be equal to minus 1. So this here is what, let's say is about 6 1/4. 6 was 20, yeah, 6 1/4. So we can just simply say 6 1/4 minus 1 and get 5 1/4. Right? And that's our answer for that one. Let's go on to the next one, B. B in this case was alpha minus beta squared. Okay, let's expand that out. Okay, let's expand out that alpha minus beta squared. So alpha minus beta squared, and I'm going to write this on the side again. So I'm going to say consider, or maybe I should just write it out here. Yeah, let's just write it out there, right? So alpha minus beta squared is the same thing as saying alpha minus beta into alpha minus beta, and that is equivalent to saying the alpha minus beta squared is equivalent to saying alpha squared plus, sorry, that's minus minus alpha beta minus alpha beta, and then plus beta squared. And I can see that it is equivalent to alpha squared plus beta squared minus 2 alpha beta. All right, so alpha minus beta squared is the same as this minus this. I already have this here, right? Actually, let me just write that in blue because it is done in blue, right? I already have something for this here, which is this up here, right? So this can just simply come in, this part here can simply come in and replace this, right? And what I can get is that alpha minus beta squared is going to be equivalent to alpha plus beta squared minus 2 alpha beta minus 2 alpha beta, and that is equivalent to alpha plus beta squared minus 4 alpha beta. And we already know that alpha plus beta is 5 on 2 and a half, so we have this here is going to be equal to 5 on 2 squared minus 4 into a half, and that there is 25 on 4 minus 2. If I want to make this the same thing, I can just simply rewrite this. I can multiply the top by 4 and bottom by 4, since this is over 1, and I will be able to get 8 on 4. And then I can say 25 minus 8 is going to be 17 on 4, and no 4 4s are 16 and a quarter. Right? So 4 and a quarter, that's the answer. Let's go on to the third one. Right? Example 3. So in example 3, we have the roots of a quadratic. The roots of a quadratic equation are 3 times the roots of x squared minus 4x plus 3 equals 0. From the new quadratic, sorry, not from the new quadratic, form the new quadratic, right? And we can see here that if alpha and beta are the roots of the quadratic equation x squared minus 4x plus 3 equals 0, we can say then we know the sum alpha plus beta is going to be equal to, you know what, let me just rewrite this a little bit more for you. So I'm just rewriting it here so you can see my thought process instead of me just writing out the answer. Plus 3, right? So then I can see that alpha plus beta is going to be equal to 4, and then alpha beta is going to be equal to 3. And if the new quadratic has roots 3 alpha, in other words 3 times the one of the root and 3 times the beta root, then we can say that 3 alpha plus 3 beta is the sum of the roots. I think that's right. Then the sum of the roots, and obviously is equal to 3 alpha plus 3 beta, which is 3 into alpha plus beta. And that would be equivalent to 3 into alpha plus beta is over here, 4. Right? So I'm just going to put here 4. And that gives me 12. Right? Let me go on to the next page. The next part, I'm supposed to have the product of the roots. Right? So the product of the roots, the product of the roots is going to be equal to 3 alpha into 3 beta, which is 9 times alpha beta. And alpha beta up here is 3. So I'm going to have 9 into 3, 27. And then I can say from x squared minus sum of roots x plus product of roots equals 0, we can say that x squared minus the sum of the roots is 12. 12x plus 27 equals 0. So that's x squared minus 12x plus 27 equals 0. That's the new quadratic equation with roots that are 3 times the roots of this equation here. Right, so let's move on now into today's lesson. And today's lesson is about solving simultaneous equations. Just write that title here. Solving, right, change that color. Solving simultaneous equations. Right, solving simultaneous equations. And the objective, I'm going to write the objective in blue. Again, objectives come straight out of the syllabus. Objective, right. Objective is to solve 2 simultaneous equations in 2 unknowns in which one equation is linear and the other equation is non-linear, right? And the two situations that we're going to look at in this one is the quadratic. Just put this pencil here, right? So the two that we're going to look at is, one is the quadratic, and the other that we're going to look at is the circle, right? So all you're going to be doing is solving simultaneous equations. Now, when you're solving these types of problems, what usually happens is that we'll use the substitution method. And once you're finished using the substitution method and you do a little bit of simplification, you end up with a quadratic equation. And the quadratic equation that you end up with, all you have to do is use the methods that you already know, and you'd be able to solve the problem. You'll get 2 values for x. Then you take those 2 values for x, you put it into the linear equation, and you'll get 2 values for y. And then you get 2 sets of answers. Those 2 sets of answers are really the points of intersection between your quadratic and your line, or your circle and your line. There's a few types of intersection. Let me just write this over differently. Types of intersection. Right? There's a few types of intersection. So you'll have 2 intersection points, right? Which would imply 2 real solutions, right? And in cases like when you have a circle, you might have something like this. You have 1 point here and a line going straight through, and the next point here. So these are your 2 points of intersection here and here, right? And then you have a situation where you'll have 1 intersection point, 1 intersection point, and this is usually going to imply that you have a tangent. And in that kind of case, what will usually happen is you'll get repeated solutions. So just change color of this so you can pay attention to the note. So you'll get 1 repeated solution, right? So for that kind of situation, it will look something like maybe quadratic here, You'll have this 1 point. Let me see if I can draw a line that touches 1 point. Yeah, that's cool. Right? So it's going to touch like 1 point on the curve itself. And then the last one that you can have is no solution, no intersection. And from no intersection, it would imply that you have no real, I'm just putting it in bold, no real solution. Right? And in that case, you might have something like this, right? Something like that. Okay. These are the types of intersections that you expect to get most of the time when you're solving this problem at this level. At higher levels, you will start dealing with that at your higher levels in CAPE and whatever. But right now, these are the types that you would most likely encounter. All right. So what I'm going to do first is I'm going to state in steps what you're going to have to do. And then I'm going to solve some problems so that you'll be able to do it. Okay. I think that would be best. So let's put here steps. Yes, and let me just put it in yellow. I like yellow. Right, I like green too. Okay, so first one is to rearrange the linear equation to make one variable the subject. Right? And most of the time what I would do is I would usually choose y. I usually choose y. Right? That's what I usually choose. The next thing you're going to do is you're going to substitute this expression into a non-linear equation, right? And the third thing you want to do after you substitute is to simplify. Yeah, simplify to get a quadratic in one variable. And then from there, you're going to solve the quadratic using your preferred method, right? And then we can substitute each value back into the linear equation to find the corresponding y. All right, and once you follow those steps, you should be able to solve any problem involving this objective. Right? Let's go and do some examples now. So let's say example one. Say example one. Example one. Solve the simultaneous equations, and to solve the simultaneous equations, y equal to 2x squared minus 3x plus 1, and then y is y plus 2 equal to 4x, right? And let's go with a proper written solution. So we can start off with saying given y plus 2 equals 4x, and I'll label this equation 1, and then y is equal to 2x squared minus 3x plus 1. This will be labeled as equation 2. And I'm going to say rewriting 1, right? So I'm going to rewrite 1. RITE1. Rewrite 1, I'm going to get that y is equal to 4x minus 2. Right? I'm going to label this equation 3 just to make things easier for myself. All right? And then I'm going to say substitute for y in 2 with 3. Right? So I'm going to take this and replace this here with this. Right? So I'm going to have here, just simply take this and put a c. Since y is equal to that, I'm just going to replace that with that. So I'm going to have here 4x minus 2 is going to be equal to 2x squared minus 3x plus 1. And we're going to simplify that. I'm going to put everything on one side. I'm going to have 2x squared minus 3x minus 4x plus 1 plus 2 equals 0. I'm going to simplify again. 2x squared minus 7x plus 3 equal to 0. Right, and that's the quadratic that I have to solve. The first thing I want to do is I want to try and see if I can factorize it. Factorization will work easily sometimes. So 2 multiplied by 3, positive 3 is going to give me a positive 6. I'm going to have 1 by 6, 1 by 6, 2 by 3. And this one here comes closest to 7. If I say negative 6 multiplied by negative 1, I'm going to have positive. If I multiply it, I'm going to have positive 6 over here. And then if I add it, I'm going to have negative 7 here. So I can go through this. I can say 2x squared minus 6x minus x plus 3 equals 0. Factorizing is what I'm doing. So it's 2x into x minus 3, and I'll say minus 1 into x minus 3 equals 0. And I'll have x minus 3, then I'll have 2x minus 1 equals 0, and that there is my factors. Now that I have my factors, I can basically say since x minus 3 and 2x minus 1 are factors, then using my factor theorem, I can say x minus 3 is equal to 0, 2x minus 1 is equal to 0, and that would mean that x is equal to 3 and x is equal to a half here. And I can say using x equal to 3 in equation 3, I will get that y is equal to something. What was it again? 4x minus 2. So 4 into 3 minus 2, which y equal 12 minus 2, which is 10. And then using x equal to a half in 3, I can see that y is equal to 4 into a half minus 2. Y is equal to 12. Oopsie, I'm watching up here. So this is 2 minus 2, which is equal to 0. Right? So hence the solutions are, and we can have 3, 10, and a half, and 0. Right? Right, good. Yeah, that's fine, everything there. And just remember that these are points of intersection. Right? These are points of intersection between the equation, whatever shape this makes is a quadratic equation here, and whatever shape this makes as a straight line there. Right? So these are 2 points that they're going to intersect at. Let's do another one where we're looking at a circle. Right? So let's say example 2, solve the simultaneous equation y equal to x plus 1, and we have x minus 2 squared plus y minus 3 squared equal to 9. And then from there, what we can do next? Let's start the solution. So given y equal to x plus 1, and we'll call this equation number 1. And then let's see, then we have x minus 2 squared plus y minus 3 squared equal 9. I'll call this equation number 2. Right? Should really line these up a little bit more. Let's just do this as 1, this as 2. Right? Okay. So I label these 2 here. And from there, I have to do the substitution. So I'm going to take this here and substitute it here, because y is also equal to x plus 1. So replace y in 2 with 1, right? I can say with the right hand side of 1, right? Up to you however you choose to with it. So I'll have x minus 2 squared plus open bracket, that's x plus 1 minus 3 close bracket squared equal to 9. And I have x minus 2 here squared plus open bracket x minus 2 here squared equal 9. Oh, this is nice. No, okay, here's what's happening here, right? I have two of the exact same things, so this works out really nice, right? I can just simply write 2 into x minus 2 close bracket squared is equal to 9. That simplifies a lot of things. If it is that it was not like that, what I would have to do is I would have to expand this, and I would have to expand this, and then I would have to simplify it, and then put it equal to 9, and then I'll get a quadratic to solve. But that's not the case of what's happening right now. Okay, so this here is really nice. X minus 2 squared equal to 9 over 2. And then that would mean that x minus 2, I could just leave that as it is equal to the square root of 9 over 2. So plus or minus square root of 9 over 2. And then we can have here that x would be equal to 2 plus or minus 3 over root of 2. Now, I can leave my answer like this for my x values. When we do SIDS later on, you can get an answer. You can make this answer look a little bit nicer, right? You're not really supposed to leave the answer like this. I can probably put in the approximate value for it. So let's do it like that then. I don't really want to though, right? I don't really want to. Yeah, let's just do it like that. I'll just do it now so you can see exactly what happens with later on. So with this one here, I can say that this here is same as writing 2 root of 2 over 2 plus or minus 3 over, sorry, root of 2 and then root of 2. So I can have the LCM as root of 2. So I can say something like root of 2 and I can say 2 root 2 plus or minus 3, right? And then what I can do is I can multiply the top and the bottom. I can multiply the top and the bottom by root 2, right? Root 2 over root 2. And I can have here, this will be 4 plus or minus 3 root 2 over 2, right? That becomes that. So I can rewrite x here as 4 plus or minus 3 root 2 all over 2. And when you do SIDS later on in the lesson, you'll be able to understand this as well. Okay, so let's move on from here. So I have x, I need to find y. So right, so if I have to find y, I'm going to say using x equal to 4 plus 3 root 2 over 2 in 1, and 1 is this, so x plus 1. I'm just going to say y is equal to x, which is 4 plus 3 root 2 all over 2 plus 1, right? I can do the same thing I did before and write this over. I can multiply the top and the bottom here by 2, which is 2 over 2, which is essentially 1. So I can get something like this. So it will be 4, oh, sorry, not 4. Y is equal to 4 plus 3 root 2 plus 2 all over 2, which is the same as 6 plus 3 root 2 over 2. I can probably do something like, I'll leave it just like that for now, I guess. This here can simplify into something, but I'm just going to leave it as it is. You know what, let me just write the simplification. This is what you would end up simplifying it to later on. So you have 3 into 2 plus root 2, and then all over 2, right? That is what it would look like in its simplest form. Let's do on the next one as well. So using x equal to 4 minus 3 root 2 all over 2 in equation 1, and we see that y is going to be equal to, what is it, 4 minus 3 root 2 over 2 plus 1. And the answer will just be the same thing, except it's going to be, what is it? It's going to be 6 minus 3 root 2 over 2. That's going to be the answer. And simplifying, it's going to give me something like this, right? Don't know why that just popped at the bottom, right? Let me just pull that down. Shoot. Hold on. Pull that down and I end up losing something. Okay, right, yeah, let's go. Okay, so continuing from there, I have that 3, 2 plus root 2 all over 2, right? And therefore that means the solution, so just change that. So this, hence the points of intersection are, it's going to be, just put this here, this will be 2 plus 3 over, no, let me just write it in the form that we had it before, so let's put it in this one. Yeah, let's put it that one. Let's put it this one. So we're going to put it in the form 4 plus 3 root 2 over 2, and then that's going to be 3 into 2 plus root 2 all over 2. That's 1. And the next one, and it's going to be 4 minus 3 root 2 over 2, and then 3 into 2. This here is a minus, not a plus. Yeah, minus root 2 all over 2, right? And that's going to be it. That's going to be the end of that, right? Again, this is surds. Right now, you can just round off to the nearest decimal place, and that will be fine for now. But when you learn surds, you would expect that your answer is in surd form rather than in a decimal rounded off. Okay. And with that, that would be it. That's all you have to learn to do for this lesson, right? Nothing too difficult as long as you're able to solve a quadratic and you're able to substitute into a linear equation, you would be able to get your 2 points very easily, right? Let's get some exercise questions that you can practice now too. So exercise, all right? Solve each pair of equations, right? And I'm going to write the equations one color in, one color out, because it's really easy. 3x squared minus 2x minus 5, and the other equation is y plus 7 equal to 5x. Let's write this in yellow. Next one, number 2, y plus 5x equal to 6x squared plus 2, and then we have y plus 4x equal to 3. And then we have number 3 is y equal to 2x plus 1, and then we have here x minus 1 squared plus y minus 2 squared equal to 10. And then the last one, number 4, it's y equal to minus x plus 4, and then we have x plus 3 squared plus y minus 1 squared equal to 25. Right? Those are your questions to try. Right? If you see any issues, you have any questions, you have any problems, you can also ask me, and I'll be helping you get through it. Right? Let me know if this helps. Thank you. Enjoy the rest of your day. Bye.